we're starting now the next filter, which is your bypass band pass filter. So if you want to pass a band between frequency range from omega 1 to omega 2, so you can do by cascade of low pass and high pass filter. Suppose you have say a low pass filter and you're applying signal here, say V input, and the cutoff frequency of low pass filter is omega 2. This omega C is omega 2. Cutoff frequency is omega 2. And then the output of low pass filter, if I pass this here, signal pass from a high pass filter, okay, of cutoff frequency omega 1, okay, you have to remember omega 2 should be greater than omega 1. And now if I put a inverter, invert this output, inverter, then you can get a band pass filter, okay, B output here. So for example, you have gain is coming of all the frequencies here. This has a cutoff frequency omega 2. So whatever gain is coming here, whatever output is coming here, that will be input of this one, and input of this one will be output of this one will be input of this one. Okay, here is only inversion. We'll put inverter and we'll make positive because I'm using the invert in my this low pass and high pass filter in the inverting configuration. So what will happen? This omega 1, this is a high pass filter. So any signal is coming to high pass filter. What it will do? If you have high pass filter, if any signal is coming here, it will pass only high pass, low thing it will stop. So I'll put the output of this one will come here. Say it will come like this here. So this is your omega 1. So so everything if you're getting the full signal, everything which is omega 1 will pass and beyond everything will be stopped. And now with low pass filter job is low pass filter. What it will do, if you signal, it will pass low frequency and stop other. And now anything above W2, anything will be W2 will be stopped by this filter. So you will get a band, you will get only band. You will get only a band of frequency. So this way you can create a band pass filter. Now let us write the output. You can put high pass filter here, low pass filter here. The only thing is the frequency you should know. Omega 2 should be greater than omega 1. And then you can pass the band. And yesterday we already seen the circuits for low pass and high pass filter. Does anyone remember the circuit? So let us draw the circuit now. First draw the low pass filter, then high pass filter, and then inverter, and then we'll write the output. So I'm erasing this one. So let us first draw the low pass filter. So what is low pass filter? Is a minus plus and this is C here. And low pass filters, I'm I'm telling this is your R, and this is your C1, and this is ground. Say this is R. Here you are applying V input. Okay. And then you have a high pass filter. What is circuit for high pass filter? Now this is the output. Say this output is say V naught 1. And now here we have one more op amp, minus plus. Here you can put a resistor more. You put a capacitor, one capacitor, and you put a resistance say R more here. Say this is R, this is C2. So and this is ground. So this is a low pass filter. This is a high pass filter. And now the output of this one, because it's negative, you can invert and you can make it positive by putting one more resistance here, one more RF here, and this is my final output. And then you can put ground. And now the values R1, say RI, RF. Okay, this is RI, R input, RF. Now let us write first what is V naught 1. Okay, output of low pass filter. Output of low pass filter, which I am saying it is V naught 1. Tell me what is the V naught 1? Yesterday we have done. This is minus Z1. So this is Z1 upon R into V input. Okay. And what is minus ZF? You can apply nodal analysis also, then also you can write. So what is minus Z1? Z1 is combination of this one. So this is minus 1 by j omega c R, okay, into 1 by j omega c. I'm writing for this one, Z1, and this is R plus 1 by j omega c. This is your Z1, and similarly, now this R, so this R will cancel. So this is your B naught 1, and this will be minus, if I take this common here, this would be 1 plus j omega c R. Okay, so I'm writing here, your V naught 1 is minus 1 upon 1 plus j omega c R. After solving this one. So C is here, C1. Similarly, what is V naught? V naught 2. So V naught 2 will be basically whatever V naught input is going here. This is again minus R upon this, say Z2, RF into Z2 into this V naught is input, this V naught 1. And now this is minus R and Z2 is in series. R plus 1 upon j omega C2. Okay. And this expression also you can write in a standard form. What is the standard form? Cutoff in the form of cutoff frequency. Okay, so this expression also you can write minus 1 plus j omega, and this is omega 2, which is cutoff frequency omega 2. This you can write like this also. And omega 2 will be what? Omega 2 is nothing 1 by C1R. And now similarly you can solve this one. This will become minus, okay, minus R, and this is again, this will go up, minus j omega R 1 plus j omega R C2. Of course, there is a V naught multiply, and now multiply V naught here. Tell me what will come. Where is the minus is going? This minus minus. 3 minus is coming. Okay, whatever. And now V naught is 1. V naught 1 is what? V naught 1 is this one. Minus 1 upon, and now minus 1 upon 1 plus j omega upon omega 2. And this also you can write in the standard form. So this minus minus plus. So this is 1 plus j omega upon omega 2. This one, and this one also j omega
Sir?
r. Tell me.
Sir, and V01 V input is missing, right? Into V input will come.
Here na? V input.
Yes, sir.
Now tell me what will become. This will become j omega r, and this is 1 plus j omega rc2. It become omega 1. Okay, so omega 1 is 1 by rc2, and into you have v input. This is v naught 2. And now finally you have to write the output. Now only it will be RF by RI into V input. So let me write the final expression and then you can check it. So V naught will be, say, minus RF RI 1 upon 1 plus j omega C1R j omega C2R upon 1 plus j omega C2R, or this will be minus RF upon RI 1 plus j omega 1 omega 2 and j omega C2R. This will become 1 plus omega upon C2R is omega 1. If you want, you can solve it further. Minus RF RI C2R is what? C2R is, tell me what C2R? C2R is 1 by omega 1. 1 by omega 1. So now if you omega 1, here you can make minus. Here you can make minus. If you put j here, you can make minus. Plus or minus? It's plus only. Plus only. Please you can check the calculations. I'm just writing the final answer. So what will become now? This become 1 upon omega 2 plus j omega. Okay. Omega 2 will go, omega 1 omega will cancel. So I will have a final answer j omega 2. And this is your final 1 upon omega 1 plus j omega. This you can write. Okay, only writing this much is enough. Actually, it's not required. You should really understand that how to make the filter. You should know what is the cutoff frequency. That the cutoff frequency formula you should already know. So no need to write in this form also. So it is the your band pass filter, and I will go to the next one. So tell me if any student has a doubt, we can discuss one time more. Actually, we don't require to write these things. Okay, we only have to write the output. This is output, and we know what is C1R is omega 2. 1 by C1R is omega 2, and C2R is omega 1. 1 by C2R is omega 1. That's it. So C1R is omega 2, and omega 1 is this 1 by C2R. Only this you have to remember. Similarly, we can now go for next one, band reject filter. Can anyone tell me how to make a band reject filter? How can we make a band reject filter? बताइए. Band reject means what? I want the output should be like this. That is omega 1 and that is omega 2. Now tell me how to make this kind of filter. Can we add in series or parallel? कैसे बनाएंगे इसको? So this is what? This is basically low pass filter. But low pass filter will make everything zero. So you can't make this filter. So how to make now out of this one? If I use first high pass filter, then this will come like this, and then again you put if you put a series, it will become band pass filter, but you want band reject filter. So बताओ कैसे करेंगे, थोड़ा सोच के बताओ कैसे करेंगे. यही क्वेश्चन पूछा जाता है एग्जाम में. सॉल्व सॉल्व कुछ नहीं कराता है, खाली ऐसे ही पूछता है. So if you use a low pass filter, and if you use a high pass filter, and then you sum it, इसको अगर सम कर दें यूजिंग समिंग एम्पलीफायर, भी ये मिल जाएगा आपको यहाँ से, और ये वाला मिल जाएगा आपको यहाँ से. दोनों की फ्रीक्वेंसी अलग अलग होनी चाहिए, तो बीच वाला बैंड रिजेक्ट हो जाएगा. एंड ये मिल गया, ये मिल गया, इसको ऐड कर दो, बीच में कुछ नहीं है. एंड दिस इज यू यूज समिंग एम्पलीफायर. दिस इज योर समिंग एम्पलीफायर. ये आपका आउटपुट है. ओके, और इन दोनों को आप दे दो इनपुट. सेम इनपुट दे दो, एक ही इनपुट का जिनका फ्रीक्वेंसी अलग अलग है. लो पास का फ्रीक्वेंसी बोलो ओमेगा 1, इज ओमेगा 2. तो आपकी क्या हो जाएगा, लो पास फिल्टर कट ऑफ फ्रीक्वेंसी. ओके, Cutoff frequency of low pass filter omega 1 should be less than cutoff frequency. Okay, cutoff frequency ये एग्जाम क्वेश्चन पूछता है. Cutoff frequency of low pass filter should be less than cutoff frequency of high pass filter, which is equal to omega 2. तो omega 1 should be less than omega 2. और बैंड पास में उल्टा था. दिस इज फॉर बैंड रिजेक्ट. बैंड पास में हाई पास फिल्टर की फ्रीक्वेंसी लेस देन थी उससे, लो पास से. सो दैट रिलेशन यू शुड रिमेंबर. और अगर सर्किट बनाना तो बना सर्किट बनाना जरूरी नहीं है, इतना ही पूछता है एग्जाम में. लो पास फिल्टर यू नो, हाई पास फिल्टर यू नो. ओके, नाउ जस्ट यू टू सम देम. So let me make a low pass and high pass filter. So लो पास फिल्टर क्या अभी बनाया आपने, अभी थोड़ी देर पहले बनाया, क्या था लो पास फिल्टर? बताओ. माइनस प्लस ग्राउंड. लो पास फिल्टर में क्या था आपका? यहाँ पे रेजिस्टेंस था. ओके, यहाँ पर एक कैपेसिटर था और यहाँ एक रजिस्टर था. कैपेसिटर की वैल्यू C1 दे दिया था आपने. और बाकी आप आर आर कर दो. आर आर. यहाँ पे V इनपुट दे दो. यहाँ पे जो आउटपुट आएगा उसको V01 बोल दो. ओके, V इनपुट दे दो, कॉमन दे दो V इनपुट. और नाउ यू मेक ए हाई पास फिल्टर. क्या आएगा? सीरीज में रजिस्टर एंड कैपेसिटर. इसको C2 बोल दो, इसको भी R बोल दो. एंड दिस इज ग्राउंड. दिस इज योर V02. अब समिंग एम्पलीफायर में क्या होता है? समिंग एम्पलीफायर में यू हैव अ इन्वर्टिंग कॉन्फ़िगरेशन, माइनस प्लस, दिस इज ग्राउंड. And here we use this output. So say a signal is say a RI which is used here. यहाँ से भी एक RI combined summing amplifier, and this is going here, and here you have one RF, and this is your final V0. Now you already know what is V0 and this one, so you can directly write the output now. Now this output will be what? This output will be minus RF upon RI common V01 plus V02. और V01 V02 पहले हमने लिखा ही था. हमने क्या था? RF अपॉन RI माइनस 1 प्लस J ओमेगा C1R. ओके, माइनस माइनस बाहर चला जाएगा तो प्लस हो जाएगा, प्लस J ओमेगा C2R, ये वाला आउटपुट C2R 1 plus J omega C2R. This is the output.
इसमें सर
हाँ।
सर ये एक ही आर आई रेजिस्टेंस आएगा।
हाँ,
आर एफ के नीचे सर एक ही रेजिस्टेंस आएगा सर आर आई।
ये वाला
हाँ सर।
एक क्यों आएगा? अलग समिंग एम्पलीफायर है ना, समिंग एम्पलीफायर कैसा होता है? दिस इज माइनस प्लस, बहुत सारे को ऐड करते हैं हम लोग, V1 V2। तो अभी इसको इसको ऐड कर रहे हैं तो RI के थ्रू देंगे, फिर सम करते हैं ना सबको। ये हो गया RF RI V01, फिर इसको RF RI V02। समी एम्पलीफायर तो ये होता है, जितने भी ऐड
हाँ सर।
करने
हाँ
हो
सर।
ये सब ऐड कर दो।
ठीक है सर।
अब दो कर
हाँ
दिया
सर।
आपने, ठीक है। अब एक लास्ट और बचा हुआ है, वो कर लेते हैं, फिर क्वेश्चंस करेंगे। लास्ट है बैंड, हाँ, ऑल पास फिल्टर। अभी हमने देखा क्या? लो पास, हाई पास, बैंड रिजेक्ट, बैंड पास। अब खाली एक ऐसा फिल्टर जो सब फ्रीक्वेंसी को पास करे, ऐसा भी फिल्टर बना सकते हैं। दैट इज कॉल्ड ऑल पास फिल्टर। वो उसका इतना इम्पोर्टेंट नहीं है, बट देखने के लिए, सॉल्व करने के लिए कर लेते हैं हम लोग। ऑल पास का मतलब क्या है? यस, ऑल पास फिल्टर। बताओ भाई, ऑल पास फिल्टर कैसे बनेगा? कोई बता सकता है क्या? ऑल पास फिल्टर। हम्म। आप कैस्केड से भी बना सकते हो और डायरेक्ट आपके पास में। पहले तो ये बताओ, जैसे मेरे पास में अभी मैंने बनाया एक लो पास फिल्टर, लो पास फिल्टर, और एक मेरे पास है हाई पास फिल्टर। ओके। अब इन दोनों से मैंने यहाँ पे इनपुट दिया और उनको सम कर दिया, समिंग एम्पलीफायर। ओके। और यहाँ हमने अभी बनाया बैंड रिजेक्ट फिल्टर। इसी से क्या हम ऑल पास फिल्टर बना सकते हैं क्या? अगर मैं बोल दूं ओमेगा 1 ओमेगा 2, इफ ओमेगा 1 इज ग्रेटर देन ओमेगा 2, तो क्या हमारे पास में ऑल पास फिल्टर बन सकता है क्या? जैसे सपोज दिस इज ओमेगा 1, so omega 1 means you have a signal coming like this, okay? And now if I say this is a low pass filter, it passes everything less than omega 1। तो ये सपोज मेरा ओमेगा 1 है, it passes everything less than omega 1 coming from here, and omega 2 passes everything beyond omega 2। so this is omega 2। ये तो फिर बैंड पास ही बन गया ना वापस। ये तो बैंड पास ही बन गया, इससे भी बैंड पास ही बन गया। ओमेगा 2 पर ओमेगा, ऑल पास फिल्टर नहीं हुआ। तो सिर्फ ऑल पास फिल्टर के लिए क्या करें? हाँ, रेंज में तो इस कंप्लीट रेंज में तो पास हो गया पूरा, ऑल पास फिल्टर बन गया। बट हमको चाहिए सारा सिग्नल। ओके, सो क्या कर सकते हैं इसके लिए? यू हैव दिस वन, द सर्किट इज माइनस प्लस, दिस इज योर हियर, एंड you apply here also some input. This is your V input, this is R, this is R, this is your C, and this is your RF, this is the V0। तो इसमें क्या होगा? आपने कुछ सिग्नल दिया, ये क्या करेगा? हाई पास को ब्लॉक कर देगा, लो पास यहाँ से चला जाएगा इधर, ठीक है। हाई पास ये यहाँ से पास नहीं करेगा, हाई पास यहाँ से चला जाएगा। तो ये आपका बन जाएगा। इसका लिखो आउटपुट लिखो, अभी देखते हैं ये हाई पास फिल्टर है कि नहीं है। राइट द आउटपुट ऑफ दिस वन। So if I want to write the output, I should know what is B plus. Okay, output is what? Output is basically sum of both the things. So minus RF by, if this is 0, here is coming 0 because inverting non-inverting both are there. Right? So I'm using superposition principle. So this will be minus, or you can say this is V plus, so this is also V plus. So now I can write directly V input minus V plus divide by R, like this. I'm going, and I'm going from V plus to minus V naught upon RF. Now you can tell me what is V naught. V naught is minus V naught RF or plus V naught RF. Tell me what is the V naught RF? V plus RF minus V input R and plus V plus upon R. Solve this one. Tell me what is V naught is coming. Or you directly write this is coming here minus this going here, this is here, this coming here. V input minus V plus upon R. And now V plus, you know what is V plus. V plus is this one, 1 by J omega C R plus 1 by J omega C into V input. So this is basically V input upon 1 plus J omega C R. V plus value, put it here. And now solve it and tell me what is the answer is coming. So V plus, which is V input, okay. बताओ सॉल्व करके बताओ क्या आएगा, सिंपल सा एक्सप्रेशन सॉल्व करके बताओ क्या आएगा। अगर इस यहाँ पर हम दोनों को आर को बराबर कर दे, इसको भी मैं आर एफ कर दूं तो सिंपल हो जाएगा ना। रेजिस्टेंस बराबर कर दें तो कट जाएगा आर एफ। देन व्हाट बिकम, इफ आई से दिस इज कैंसिल आउट, तब क्या हो जाएगा, तब दिस इज माइनस, इसको प्लस 2V प्लस, okay, 2P plus. So V naught will be 2V plus minus V input. That is correct. V naught will be 2V plus and V plus, now you know, 2V input 1 plus J omega CR minus V input. And now you can take V input common, 2 plus 1 plus J omega CR minus 1 V input common. And now gain will be what? Gain will be V naught upon V input. This will be 1 minus, we solve this one. So 1, 2 minus 1 plus J omega CR
Or 1 minus.
minus 1 minus, sorry, upon 1 plus J omega CR. This is the gain. Now this is the all pass filter. We'll see how. बताओ ये कैसे ऑल पास फिल्टर है? इसको सेम रखना जरूरी है तो सिंपलीफाई हो जाएगा ना, अदरवाइज थोड़ा सा एक्सप्रेशन इजी नहीं आएगा। आएगा तो वो भी ऑल पास फिल्टर, बट एक्सप्रेशन इजी नहीं आएगा। तो इसको बराबर रखने हाँ, टेल मी।
सर अगर सर सर ओमेगा सी अगर इक्वल हो जाए तो बन सकता है क्या सर?
क्या?
ओमेगा सी इक्वल हो जाए तो, ओमेगा सी अगर इक्वल हो जाए तो मतलब
तो यहाँ पे तो ओमेगा सी है ही नहीं ना। हाँ, ओमेगा सी इक्वल हो जाए तो फिर क्या है? तो फिर
सर
वो
ऑल पास वेक्टर बनेगा सर?
नहीं, वो तो फ्रीक्वेंसी रेंज हो जाएगा ना। अभी देखो ये ऑल पास फिल्टर है ना, अभी देखो ये इसमें क्या हो जाएगा आपका, इफ आई राइट द मैग्नीट्यूड ऑफ दिस वन, ओके, व्हाट इज मैग्नीट्यूड? दिस विल बी अंडर रूट 1 + ओमेगा² C² R²। नीचे का भी क्या आएगा? 1 + ओमेगा² C² R²। ये कैंसिल हो जाएगा, तो क्या आ गया आपका? गेन क्या आ गया? 1 आ गया। इंडिपेंडेंट ऑफ फ्रीक्वेंसी, इंडिपेंडेंट ऑफ फ्रीक्वेंसी, that means all frequency are passing, it will give the gain with all frequency same gain. So that means the gain is independent of frequency. कहीं पे भी जीरो कहीं पे भी जीरो नहीं हो रहा है। So this is all pass filter. Now you can write the phase. What is the phase of this one all pass filter? यहाँ का phase कितना है? ऊपर का phase. So phi, this is phi 1, this is phi 2. Okay, phi 1, phi 2 means this I can write as a magnitude into eta phi 1. This I can write magnitude into eta phi 2. That is the meaning. And the differentiation will be e power phi 1, eta phi 1 minus phi 2. Just understand this one time. This is very useful. Finding the phase is very useful क्योंकि बहुत से क्वेश्चंस एग्जाम आते हैं। जैसे मेरे पास में अपसाइड टॉप I have x1 plus jy1, okay, something magnitude, and I have x2 plus jy2. Now I can write this is as a magnitude into e power iota phi 1. Similarly, I can write this is as a r2 e power iota phi 2. And now what will become? This become r1 by r2, and this number, say some number, say z. This will be magnitude r1 by r2, and phase will be iota phi 1 minus phi 2. So I'm saying this is the phase phi 1 minus phi 2. So phi is your phi 1 minus phi 2. So I'm directly writing now the phase. Gain, you know, it passes all the frequencies. Okay. Now let me write the here what is phi. Phi is phi 1. Phi 1 means this is tan inverse omega CR. And this is plus tan inverse omega CR. So this become minus tan inverse omega CR. So the phase become minus 2 tan inverse omega CR. This is the phase. And now if frequency is 0, tan inverse 0 कितना होता है? Phi 0. If frequency is infinite, phi will be pi by 2 minus pi by 4. कितना आएगा? If the phase is infinite, tan inverse infinite is how much? Pi by 2. So this will be pi by 2 minus pi by 4. It should be like this. Let me check. Pi by 2 pi 2 pi by 2 to cancel, so minus pi. अभी किसी को डाउट तो पूछो इसमें. Let me do some problems. Yes, Amarpreet, Shekhar, is that point clear to everyone?
Yes.
Okay. Now let us. ना अभी क्या खाली नंबर इस जो हमने अभी तक जो भी किया है उसमें खाली नंबर डालना है. सवाल तो सब एक डेरिवेशन तो सेम वे से रहेगा. Just you have to put some numbers. So say you have plus minus this is 10 kilo ohm. Okay, this is 10 kilo ohm and this is 10 kilo ohm and this is grounded, and here you have a capacitor which is again grounded. You have a capacitor here which is also grounded, and then you have a resistor here, a resistor here. This is also 10 kilo ohm, this is also 10 kilo ohm, and this is V input you're applying here. Okay, now you have to find the cutoff frequency. Find FC, cutoff frequency FC, and gain at zero frequency. Go to cutoff frequency, gain at zero frequency, and you tell me is a high pass or low pass filter. And there's a capacitor C, and C value is 0.1 microfarad is given. Now tell me, is a high pass or low pass filter? By seeing circuit, we have already seen circuits. By checking circuits, tell me it is a high pass filter or low pass filter. Check the previous circuits. बताओ इसको. अरे तेज कुमार, कौन सा ये हाई पास है कि लो पास है, और इन्वर्टिंग है कि नॉन इन्वर्टिंग है? चार बताए थे हमने. विल डिस्कस 4 थिंग्स.
High pass filter.
हाई पास, ये हाई पास फिल्टर है. अमरप्रीत, ये हाई पास है कि लो पास है? अपर्णा, हाउ टू चेक?
low pass,
लो पास. योशिता,
low pass filter,
low pass. Yes, because this is already minus. This is the negative feedback, and this is grounded. If you apply high frequency, this becomes zero. So here zero will go. That is, it is not passing high. If you put low pass, this will become open. And if it is become open, what is the V plus? Tell me, what is the V plus here? What is the V plus here? If it is open, what is the V plus here? Directly V input is coming here because the no current is flowing, no current is going here inside. So here no voltage drop. Directly this voltage is going there if it is a low pass. Low frequency, higher frequency, very high frequency, this becomes zero. So zero is going here. In between, some voltage is going there, and whatever voltage is here, that is coming here. Okay, so write the expression. What is the expression? We know this is a low pass filter. So low pass, what is the expression for low pass filter? So you know this is V plus. What is V plus? We already know the formula. Directly you can write the formula. What is the formula for V output? Tell me. For low pass filter, non-inverting, what is the formula? Tell me. What's the formula? Say this is R1, say this is R2, and I'm applying it non-inverting. So non-inverting formula is what? 1 plus R2 by R1, 1 by R2 plus by R1 into V plus and 1 plus R2 by R1. What is the V plus here? V plus, say this is C. So whatever coming here, that is will be your V plus. Here say this is V. So instead of writing V plus, you can write this V here. Okay, V, and V is 1 upon J omega C. And if you can say this is R, this is also R. You can directly put the formula, but this is one time I'm doing more. So use R plus 1 upon J omega C. Okay, so this become 1 plus R2 by R1, 1 plus J omega C R. One cancel out. So this is the formula. This is what? This is a DC gain, A DC, or at zero frequency gain, A naught. And this is your 1 plus J omega. And now you can write CR is the cutoff frequency, omega C. This is your low pass. If you put a high infinite, this becomes 0. If you put low, 0, okay, you get the gain. So this is the gain formula. You should remember this formula. Now he's asking what is W0. So A at W0 will be equal to 1 plus R2 by R. Now what is R2 by R? 1 plus 10 kilo ohm, 10 kilo ohm cancels out. This is 2. So this is the value. Now this number you can convert in the dB. What is gain and what is a V0 in dB? That will be 20 log 10 2. Tell me what is the value? कितना हो जाएगा? What is log 2 value? What is the log 2 value? Tell me. 10. How much?
Sir, log 2 is 0.3.
0.3. Okay, into 20. How much will come?
6.0.
60, huh? 6 dB. Check karo. I don't know what, I don't remember what is the value of log 10.
It's 6.
6. So his answer is this is 6 dB. Okay. And now what is next? He asking in the question cutoff frequency. What is cutoff frequency? Tell me. Cutoff frequency omega C is 1 by CR. Okay. And FC will be 1 upon 2 pi CR. Now what is 1? This is 2. This is 3.14. C is 0.1 microfarad. And R is 10 kilo ohm. R is 10 kilo ohm. Solve this one. How much coming? So this is 10 power 10 power 10 power 10 4 6. Okay. So this is 10 power here 1000. How much coming? You solve this one. So this should come 1000 upon, because this is 7, and this is 4. Okay, so 3 will go 1000 upon 6.28, and the answer is coming 159.235 hertz. चेक करो ये आ रहा है क्या सबका कट ऑफ फ्रीक्वेंसी? ये आंसर है आपके पास, और क्या है? Aparna, are you getting? Rishita?
Yes, sir.
Okay. So then that's now the formulas. You have to clearly sit in some time, 5-10 minutes, watch the formula. Okay, how we drive, how do we drive the gain formula? And now exam में क्या आएगा? Exam, this will, some number will be given. Either it will ask cutoff frequency, what is the cutoff frequency? Either it will ask what is the gain at 0 frequency, infinite frequency, or some other frequency, what is the gain value? Okay, this you understand the formula. Or sometime it will ask the phase. What is the phase? You should know the phase formula. At what frequency, what is the phase? Those type of questions will come. Practice questions I will give later. Okay. So let me do one more question. This is minus plus. So R2 is C and this is R1. Here I'm applying V input. Okay. So it says, C is given 10 nanofarad. Okay. R1 is given 1 kilo ohm and the FC cutoff frequency is given 5 kilohertz. So it's telling what is the value of R2. Okay, give me the value of R2. Calculate the value of R2. ये हाई पास है कि लो पास है? Tell me. This is high pass or low pass? If high, this becomes 0, everything becomes 0. So this is a low pass filter. And what is the formula for this one? V naught or gain. Tell me what is the formula? Anyone remember? Minus R2 by R1 1 plus J omega C R2. Check me, tell me if this formula is correct or not. You can directly, if you don't remember like this, you can calculate it within minutes also. If you apply, say, nodal analysis, this is 0. If I apply nodal analysis here, so this current is coming here, this is my node, this current is coming here, this current is going here, this current is going here. If I say this is I1, I say this is I2, if I say this is I3, so I can directly write, na? Okay, what I can write? Incoming current equal to outgoing current. Incoming current is I1 at this node. Okay, I1, and outgoing current is what? I2 plus I3. I1 is what? I1 is V input. This I'm telling different method. V input minus 0 by R1. And I2 is what? I2 is 0 minus V naught. That is minus V naught upon, this is 1 by J omega C. 1 by J omega C. That, and this I3 is what? I3 is 0 minus V naught. Again minus V naught. Okay, upon R2. R2. Now you can directly find what is the formula. V input upon R1 minus this becomes J omega C plus 1 by R2 omega naught, and omega naught will become R2. Okay, this R2 will go here, minus will go here, minus R2 by R1 1 plus J omega C R2, which we have written. Directly you can write. Either you write it as Jaidev, then RF, or either you directly you can apply like this. You can solve like this. Nodal analysis. So cutoff frequency is given 5 kilohertz. Okay. And what is cutoff frequency here? Cutoff frequency is here 1 by CR2. That is FC is what? 1 upon 2 pi C R2. Now if you want R2, R2 will be 1 upon 2 pi FCC. Now 3.14 FC is given 5 kilohertz, and this is 10 nanofarad. 10 into 10 raised to power minus, nano means minus 9. Tell me what is the value of R2? कितना आ रहा है R2 बताओ, मेरे पास आंसर नहीं है. So R2 will be how much? This is 5, 6.28, 6.28, 62.8. And power is how much going? 10 raised to power 3, 4, 10 raised to power 5. Okay.
Sir,
Now
3.2 kilo ohm.
62.8. 3, sure. अरे भाई ये क्या हो गया? 10, 4, 5 हो गया ना, 5 तो ये हो गया. अब ये हो गया 10, 3.1. तो again you can write this become 5 plus 2, 10. 10, 10, 100, 100 and this 10 is to power 4. So 10 is to power 4. हाँ correct. 10 is to power 4 divided by 3.14. So कितना आ रहा, कितना बता रहे हो? ये आना चाहिए
Sir,
किलो में.
3.2 kilo ohm.
3.2 or 2 point something.
3.2.
Huh? 3 or 2?
3.2.
How 3 point? Oh, 3 point. Okay, 3.2 kilohertz. Okay. 339. Correct. 3 point correct. ठीक है. Now how much time is remaining? Okay. So let us start now new topic. Now this is filter is completed. Now we'll start the non-linear properties. Non-linear applications of op-amp. Now we'll do non-linear application, and last we'll do the positive feedback. Okay. So non-linear application means the first application we can make a logarithmic amplifier. Logarithmic amplifier. These are just circuits to be remembered, nothing else. So you have a minus plus. Here if you put diode, directly connect to the non-linear means now diode is there. Diode or transistors there. They are non-linear devices. V naught, you put ground. Say this is R, and you put a V input here. And I'm saying now that this is 0. So obviously current will go here. Here no current can go here, so this current will go here. So now write the equations, because you know the diode current equation. Okay, what is the value of forward current? So if I say this current is say I1, and I say this is the forward current, so I can write I1 is equal to IF. And the diode forward current is what? Diode forward current is given by I naught. Diode current is I naught exponential Q voltage across the diode eta kT minus 1. This is the diode equation. This is the diode equation. And if I want to write the forward current, I'm assuming this is negligible. 1 is negligible. So I can write I naught is equal to, say the voltage here is VD exponential QVD by eta kT. And now VD is what? VD is 0 minus V naught. That is minus V naught. Okay. So my current will become IF will become I naught exponential minus QV naught upon eta kT. V naught will become negative because the inverting configuration, so this will become positive. Okay. So we'll see that one later. Now what becomes? You have I1. I1 is V input minus 0 by R, and that will be equal to I naught exponential minus QV naught by eta kT. So my V naught will become now V input, this one, divide by I naught R. Okay. V naught R. And then what you can write? N kT upon Q naught. And kT upon Q naught. Okay. And log of this one. So now this become your, and now V naught should come to negative only, because the inverting configuration and is eta is positive, everything is positive. So this whole quantity is positive. So V naught should come negative. That's why it's a negative sign. So the option will be given. Okay, sometimes student they put plus sign. This should be minus because it's an inverting configuration. V naught should come negative. So this is now your output is what? Your output is proportional to logarithm of your V input. That's why this is called logarithmic amplifier. So whatever input you यहाँ पे दोगे उसका आपको log मिलेगा, log बन के मिलेगा. ऐसे ही इसका we can just make it reverse of this one. Instead of logarithmic, we can make anti-logarithmic amplifier. Just go to replace diode using here, R using there. Okay, we can solve this one and we can get. So let me stop here. Let me stop here. And begin tomorrow.
Thank you, sir.
Any question?